The next session is by Jon Skeet, and Jon Skeet is maintainer of Noda Time for one of the things that he does. And he's also well known for his work on Stack Overflow as one of the top ranking contributors there and answers of questions. Jon will take us on a journey on working with date and time, the data in .NET, because it's not as trivial as you might think. It's actually quite complicated. Jon will tell us all about it. Oh, there you are, Jon.
Hi.
Hi, I was already introducing you, so glad you could join us. Well, since you're here now, I mentioned that you're a contributor on Stack Overflow and maintainer of Noda Time. You'll probably go into the details on how to work with time and date in .NET. But as just a side question, Noda Time, where does the name come from?
So it's a .NET port of Joda Time originally. Back before the java.time package, there was the terrible Java util date and Java util calendar built-in classes. And then a bunch of folks, including Stephen Colborn, came up with Joda Time, which for a decade or so was the way to do dates and times in Java. And when I gave a talk on various things around data types and the mess we've made, I had to say, yeah, and if you're using Java, you should use Joda Time. And if you're using .NET, there isn't anything better than date time. So I felt I had a sort of moral obligation to try to fix that. And it started off with the engine underneath Joda Time ported fairly directly but hidden, and then a slightly reduced and streamlined, and hopefully I learnt some of the mistakes that the Joda Time developers made to start with and couldn't fix because of compatibility. So I streamlined that a bit and then later replaced the engine underneath anyway. So these days it has relatively little code in common with Joda Time. But still a lot of the main concepts which I'll be going through today. And of course, these days in Java, you would use java.time anyway, which itself was inspired by Joda Time.
Oh, excellent, thanks. And we dove right in, but we didn't say hi. And Jon, how are you doing?
Yeah, very well, thank you. It's a beautiful day here in, well, Reading, just west of London. And I hope things are as well as they can be in Ukraine, given everything that's going on.
Yes, exactly. And you'll be doing the session live, so fingers crossed that everything works out as well.
Yep.
I'll give you the floor. I'll be back at the end for some Q&A. There's about 5 minutes, and we'll see well what you have in store for us. So enjoy, Jon. Enjoy, audience. Here's Jon with working with date and time data in .NET.
Thank you very much. Okay, folks. So this is normally, well, I can go on about this topic for ages and ages and ages. I would usually give an hour and overrun. So cramming things into half an hour is going to be slightly tricky. But the main thing to get away from this talk, to take away from this talk, is that it is worth looking into this more. You won't actually learn facts from this talk as much as ideas that you should go and research further. I tend to find that's the way with talks. I gave up long ago in trying to say, right, this is all you need to know. You will go away from this talk completely educated on the topic. It's more, I'm encouraging you to find out more. So what I'm going to go through today is a little bit of why we're having this talk at all, then go through a bewilderingly large list of concepts. And I apologize for that in advance, but I'll explain why. And then the rest of the talk, I've got 3 bullet points here, but it's really stuff I've learned, some experience, things that work really well, things that don't work well, things that people say work well, and there are some gotchas. So we'll dive into that as well. But those 3 bullets are very much sort of one piece of this is the experience of using date and time data. So 2 things I won't be covering today are relativity and leap seconds. I hope that you don't need to deal with them. If you do, you probably need to have more knowledge than I do anyway, so there's probably not much for you, and you'll probably be using either code that you've written yourself to handle relativity and leap seconds, or very specialist libraries. Noda Time and datetime in system.datetime do not handle relativity or leap seconds. So know that if you need to cover those, go elsewhere and find out more. And I feel sorry for you because they're difficult subjects. So this is sort of the cause of the talk. This is the reaction many .NET developers, or many developers in general, get when they start thinking about date and time. At least experienced developers. More junior, inexperienced developers or lucky developers will happily say, yeah, that's all fine. I've got system.datetime. I know what I'm doing, and be unaware of the many pitfalls lurking around with date and time work. So it's the kind of thing that certainly with system.datetime, because it feels like an easy struct to use, you just plow ahead and don't realize all the mistakes that you could easily be making. Once you've been through that a couple of times, you see something in a requirements document saying, we will store the date of whatever it is, the transaction, the shipping date of a product, and you go, oh no, this is going to be horrendous. And you lose all your hair like me. The aim of this talk is to say it isn't simple. So if you're still in the, hey, I can just do it without thinking, it's all going to be really straightforward, then I want you to move out of that mindset. And if you're in the mindset of, it's going to be far too complicated to get right, so I'll just bodge something that kind of looks okay and hope it doesn't actually cause any problems, I want you to move away from that mindset as well. Seeing date and time requirements should induce mild, not panic, but concern, and delving into those requirements in more detail. Make sure that your product manager or whoever is in charge of your requirements is able to give you some really, really detailed requirements, and then you can turn those into code. My experience is that working out exactly what your code should do is far harder than making it do that thing, at least if you've got good tools available. And I should say, we've already said that I'm the maintainer of Noda Time, which is designed to be a better date and time library than datetime. Obviously, I'm biased, but I do think that using tooling that's designed to make your code maybe a little bit longer, you need to take a few more steps, but each of those steps is clearer and expresses every bit of intent that you need. Noda Time doesn't try to second guess you. It doesn't say, oh, I'll just use your local time zone because that's going to be fine. It doesn't say, I'll do this ambiguous conversion in a way that I've documented, but you won't get a say in it. Where you need to make a decision, Noda Time says, you need to make that decision. It's on you, but I'll make it really easy for you to express that decision. So to recap, overall, I want you to approach date and time work with caution, but optimism that you really can get it right with a bit of work. It's not trivial, but it's manageable. So this is the long list of concepts that we're going to go through. And while I've got all of them on the screen, I'll just divide them into two categories. So the first three are what I call machine time. They are things where if humanity didn't exist, but somehow computers did and were able to write code for themselves, they would only use instant, duration, and interval, which is sort of the a composite type anyway. It's not quite as bare bones as instant and duration. But after those, everything else is what's called civil time, which is what happens when humans get involved. So we've got calendar systems, the Gregorian calendar, Julian calendar, Hebrew calendar, Islamic calendar. If you don't know what that is yet, I'll come on to it, don't worry. We've got ideas like a date. A day is a very human concept. Machines don't care that the sun rises and sets. Time just keeps going for machines. But for humans, it's very naturally a useful concept. Then we've got time within the day. If you're going to have a date, then obviously there's portions within the day, and that's our time of day. Combine those and you get to a local date time. Then we get into time zones, which is unsurprisingly the trickiest bit of this talk. and then what happens when you put an instant in time or a date and time into a time zone, and then offset date and time and period will come to at the end. But those are all to do with human concepts, fundamentally because of calendar systems and dividing the timeline into dates and then time zones. But if I'm going to introduce all of these types, and I've given some of the type names over in brackets, you may be asking, well, why do I need to do any of this? Why can't I just use date time? So I have problems with date time. I've worked with a friend of mine who was maintaining date time after its initial design. He didn't get to do the initial design, but I'm sure there were legacy reasons for it being not brilliantly designed, but they are annoying. If you haven't looked at date time in detail, it has this kind property, which sounds, fine. It can be a kind of UTC or local or unspecified, but those are radically different concepts, and you should be able to do different things with them. And you shouldn't compare a date time in UTC with a date time in an unspecified time zone and say that one happens after the other, because you just don't know. But because we've only got that one type, I know we've got some more, but because for a while we only had date time, we had to make do with it and use effectively different domains with one type. It was a little bit like only having double floating point numbers as your only numeric type. And I know JavaScript at least used to be in that state. I think there have been advances since. I'm not a JavaScript developer, and I won't pretend to know enough to criticize it, but I understand that originally it only had this one numeric type, and that's a pain, because if you want to have an integer and know that it's only going to be an integer, it's useful to have that in your type system. We did gain date time offset. I can't now remember when, whether it was in .NET 2, which is a very long time ago now, or a bit later. That is useful, but it's not quite as useful as some people seem to think. I wouldn't go as far as some people think. If you use date time offset everywhere, never use date time, always use date time offset, you won't have any problems. That's just not true, because it represents a specific thing, which isn't the only thing you ever want to represent. I'm a big believer in having enough types to represent what you're trying to talk about in your code. Now, obviously, there are limits to that. You don't want a separate date type for dates that are after the year 2000, or dates that are in one calendar system versus another, etc. But fundamentally, if we've got multiple different kinds of data, it makes sense to have different types for them. Much more recently, in .NET 6, we got date only and time only, which roughly correspond to the Noda Time types of local date and local time. They are definitely good things to have. The fact that they're called date only and time only, there was a lot of debate about the naming. I was privileged to be asked to participate in that debate a little bit. I think these are perfectly reasonable names. There were problems with just calling it date or time in terms of compatibility with VB and all kinds of things. People are annoyed about this, but at least it's reasonably clear what they mean. They're not the names that we might have chosen if we'd had a holistic, we will do date and time properly from .NET 1, but from where we are, it's okay. So from date time is awful, and I've got a blog post on the Noda Time blog about what's wrong with date time anyway, which goes into a lot more detail about this. From there, let's go into the multiple concepts that are each represented. Each of these is a Noda Time type. Some of them have kind of equivalents in .NET, some of them don't. So if you want to represent an instant in time in plain .NET, you would probably use date time offset, but it's a little bit more than that. So an instant in time is something that doesn't care about what time zone you're in, doesn't care about what calendar system you're using. It's just a timestamp, effectively. So a timestamp can be represented in terms of a calendar and a time zone, for example, but fundamentally it represents something happening, and everyone in the whole universe, if they had infinitely fast communications, could agree it happened at that instant. So you want to get a representation which doesn't matter where people are, you can all agree on it. And the typical way of representing that internally is to have something called an epoch, which is like a starting point, or the sort of date time equivalent of sea level. Everything else is measured from there. If you're measuring altitude, you typically measure it from sea level, which is a bit weird when the sea levels are rising, but leaving that aside, you want a starting point, and that's your epoch. And you can say it's 10 seconds later than the epoch, or you could say it's 10 seconds earlier than the epoch. It's important that within one system, everyone agrees on the same epoch, because you would normally express the elapsed time express the instant just in terms of the elapsed time from this assumed epoch. So Unix systems tend to assume an epoch of 1970 January 1st midnight in UTC, and I realize I've expressed that in terms of a calendar system and a time zone ish, but that's just, you have to have some way of representing the starting point without getting circular. And we can all agree when that was with the Gregorian calendar system and things. So that's the Unix epoch. .NET itself, so datetime.tix, for example, gives you the elapsed time since January the 1st, 1 AD or 1 CE at midnight in, well, not in UTC, because date time could be in UTC, it could be unspecified. It's in this weird situation, but certainly a date time kind of UTC, or a date time with a kind of UTC, its TIX property really is elapsed time since the epoch of the start of 1 AD. Using what's called a proleptic Gregorian calendar. So the Gregorian calendar itself didn't start, wasn't in place back then, but applying it backwards in time, we end up with that. There are other epochs. So I think Excel has an epoch of 1900, although there's some weirdness around whether a 1900 was a leap year or not, depending on which bit of Excel you're using or something around that. I'm not an expert. So that's another example of an epoch. And UUIDs or GUIDs have an epoch of something in the 18th century. I can't remember the exact date now, but it was when I think Rome, or all the Catholic countries, moved from the Julian calendar to the Gregorian calendar. That instant in time is used as the epoch from which timestamp GUID times are measured. So hopefully we've got the idea of an instant in time. This is really useful for something like a timestamp in your database or in a log. You might add more information to it, but you definitely want to be able to get at the instant something happened. It would be awful to read log entries and say, okay, well, it happened at 8 o'clock in the morning, but I don't know which time zone that was in. So I can't tell whether that was, if I've got two log entries, one at 8 o'clock and one at 8:30, and I don't know whether they're in the same time zone, I don't know which happened first, which could be really difficult if you're trying to diagnose what's going on. So log timestamps, transaction timestamps in databases, commit timestamps, etc., all measured with instants. Now, this elapsed time bit, the blue arrow, is an example of a duration, and that is just an elapsed time, and it doesn't matter when it happened. So in Noda Time, instant is literally implemented using a duration and the assumed epoch, but a duration of 10 seconds is the same whenever it happened. So the 10 seconds between 10:25, or the 10 minutes between 10:25 and 10:35 now, for me, is the same as a duration of 10 minutes from 9 o'clock till 9:10. Okay, this is just an elapsed amount of time, and it can be negative. So a duration of -10 minutes is fine, and that's what would be used to add to an epoch to get to 10 minutes before that epoch as an instant. Compare that with, and I know I'm going quickly, all of these are more widely documented on the Noda Time website, for example. Compare durations with an interval. An interval is a start and end point as instants, and that has a duration. You can know how long an interval is, but importantly, compared with the duration, it knows its start and end time. So even though these two slides are basically the same in terms of where the blue lines are, the durations are the same, the intervals are not, and this would be used to measure, if you were trying to say what time did a race start and finish, that could be measured as an interval. And everyone in the world could agree exactly when that interval was, because we're still talking in terms of machine time, so no time zones involved, no calendar systems involved. These are just two instants, a start and an end. And this is, whereas instant and duration are sort of fundamental building blocks, interval is the simplest composition of that you could think of. It's got two instants, or you could represent it as an instant and a duration. Either of those, they're equivalent. And you can find the start, the end, and how long it is. Those are the machine time concepts. And if you can get away with only using those, your life is really simple. And in some places you can get away with those. For example, when did my HTTP request start? And I will give a deadline in terms of an instant when it must have finished, or a timeout in terms of a duration, how long it can take. And those are kind of equivalent if you know when it started. That's a nice situation to be in. We move on to the muddied waters of calendar systems, and this is where people come in, and people always make things more complicated. For reasonable reasons. Some people say we should abolish time zones, but there are good reasons for time zones to exist, because everyone wants to have noon with the sun above them and midnight with, while it's night, for example. Calendar systems could be done better, let's say. It's a pity that there are so many calendar systems. It's a natural form of human evolution, in the same way as multiple languages, multiple character sets, etc. But it does cause issues. Most people use or at least most software uses the Gregorian calendar, which is an example I've got here. And we used to use, hundreds of years ago, the Julian calendar system, and those only differ in terms of when their leap years are. But there are radically different calendar systems with different months, different sets of, when there are leap years, more differences than you can imagine. And there are some countries which use the Gregorian system for business because the rest of the world is using the Gregorian system for business. But in your personal life, you may well use a different calendar system. So if you are writing software that needs to be global, or at least needs to cater to one of those countries, you really need to think, am I writing business software where I'm arranging maybe business meetings, and it's okay to do that in the Gregorian calendar system? Or is this arranging someone's personal life, when their kids are going to the football club or whatever, and I could do with being able to support multiple calendar systems? Do not take the support for multiple calendar systems lightly. It is difficult. If you need to do it, use something like Noda Time, which makes it more reasonable, but it is a difficult area. And many bits of software will never need to do it. So when we've got a calendar system which breaks up our timeline into years, months, and days, it's natural to say, well, what is a day? I want to represent something like my birthday. And my birthday, June the 19th, 1976. So it has a year, month, day within a particular calendar system. If I try to say that I was born on June the 19th, 1976 in the Julian calendar system, no, I wasn't. out by 20 days or however much it is. So a date basically is year, month, day, calendar system. That's all it needs to represent. How it's represented internally is up to the system. It could be a number of days since some epoch. It could be literally year, month, and day as separate fields, whatever. You shouldn't need to care. In Noda Time, this is local date. In .NET, this is now date only as of .NET 6. So this isn't in a particular time zone. This is just a date. I would celebrate my birthday on June the 19th, wherever I was in the world. I wouldn't wait until it's actually my birthday in the UK where I was born. It's just a date. Within a date, we have time of day. So now we have time only in .NET 6, and that's great. But you may be wondering, well, what happened to time span? Because datetime.time of day returns a time span. And that's where things become complicated, because time span is closer to, very, very close to duration conceptually. It's an elapsed amount of time. And the time of day, you might think, is the amount of time that has elapsed since midnight, but it gets a bit more complicated than that. By the time I reach 3 o'clock in the morning, 3 hours could have elapsed, or 4 hours, or 2 hours, or potentially other amounts, depending on daylight saving time changes, if I'm thinking locally. So you can potentially use time span still, but it has different properties. It doesn't wrap round. So a time only will never represent 25 hours, which time span can, or a negative amount. It's in a different domain. You want something that will wrap round. So you say, what is 3 o'clock in the afternoon plus 11 hours? Well, it's 2 o'clock in the morning. That's nice and simple. It's not 26 hours. Once we've got a date and a time, it's natural to put them together. And this is where date time comes in. At least if you have a date time with a kind of unspecified, is equivalent to local date time in Noda Time. And so those two things go together reasonably straightforwardly. I'm very aware that I've been going relatively slowly, so we need to get on to time zones. A full description of time zones would be a long time. I'll say things that it's not. A time zone is not a UTC offset. So if you've got, oh, my client is in UTC +8, you do not know the user's time zone, because you don't know what their UTC offset might be tomorrow, for example. They might have a daylight saving time transition. And you should also avoid using abbreviations like my time zone is CST or GMT or BST. Those aren't time zones. They're sort of half time zones, but also ambiguous because they're abbreviations and multiple things can be abbreviated to the same abbreviation. A time zone is effectively a map from an instant to a local date time. So basically it says at any instant in time, I can tell you what someone's watch should say, assuming that they are up to date, if I know where they are. So it's location based. So I can say that at the instant that could be represented by 9:34 UTC on the 15th of October 2022, in John's location in Reading, which is in the Europe-London time zone, the local date and time is 10:34 on the 15th of October 2022. And in Kiev, it would be 12:35 local time. So that's because Kiev and Reading are in different time zones. And once you've got that idea that there's an unambiguous function that goes from instant to local date time, which is shown by this graph on the slide here, you think, well, what about mapping from a local date and time? I know that, for example, it's now 10:35 in my local time. Does that mean I can definitely know what time it is as an instant in UTC, just from knowing the local date and time and the time zone? And the answer is no, because, okay, at 10:35 I can. If this were 1:30 in the morning in a couple of weeks' time, I couldn't tell you for sure, because 1:30 in the morning would happen twice due to this fallback, which is shown by the second red arrow there. Basically, converting from local time to an instant is drawing a horizontal line across this graph, this function, and seeing where it meets the line. And most of the time it meets the line once. It's unambiguous. Sometimes it meets the line twice, which says this local time happened twice because we had a fallback from, in the UK, it would be 2 o'clock in the morning to 1 o'clock in the morning. Sometimes you'll find it doesn't happen at all. It never hits the line due to a spring forward, and that value is skipped. We skip from 1 o'clock to 2 o'clock, so I should never see on my watch it saying 1:30 in the morning on a date when it springs forward. That conversion, where you go from local to instant, is where Noda Time will force you to say, what do you want to do if it's ambiguous or skipped? Time zone info will do something, and I don't know what, and my guess is you don't know what either without looking at the documentation, and that's a dangerous position to be in. So that's the simplest example of where Noda Time forces you to make a decision. There are various options that you can easily take, but you have to express yourself explicitly in code. Coming to the end of the concepts, fortunately, we've got a date and time in a time zone, and also maintaining a UTC offset for handling any ambiguity. And in Noda Time, that's a zoned date time. I mentioned before date time offset as a useful tool in .NET, but somewhat limited. People seem to think that if they've got a date time offset, they know everything about a time zone. As I mentioned before, a time zone isn't the same as a UTC offset, because the UTC offset could change. This could be someone in Los Angeles recording what time they sent an email. They sent it at 9 o'clock in the morning. They were in UTC -8. Do we know what the local time would be 6 months later? Well, I said it's in Los Angeles, so I happen to know that then they'd be in UTC -7. But you don't get that information from date time offset. Date time offset is useful for representing instants because it doesn't have this kind that that date time does. You always know the UTC offset, so you can always get back to the instant. So if you have to use .NET and want to represent instants, date time offset is good for that, but don't think it's got more information than it actually has, and don't use it when you don't know the offset. If you really have well, the user said that it's 3 o'clock in the afternoon on December the 3rd, but I don't know which time zone, don't use date time offset because you don't know the offset. Finally, periods are a bit like durations, except they're calendar based, civil time based instead of machine time based. So 1 month isn't a duration, but it is a period. And calendar arithmetic is weird. Again, I've got a blog post that goes into far more detail, but things that you expect to be able to do. I will add 1 month and then take away 1 month, and I should get back to what I started with. Nah, forget it. That's not going to happen in calendar arithmetic. So bear that in mind. Anytime any requirements have the guarantee for this product lasts for 6 months. Well, what exactly does that mean? In terms of when it starts versus when it finishes, and is it when they register or when it gets shipped or when it's bought or what? So those are all the concepts. I wanted to rush through at the end because I want to talk a little bit, very briefly, about how to use them. I'm aware that time is against us. So I've already mentioned, make sure you have requirements that you know what it is you're trying to use. Every requirement, you should be able to write a note saying, this is an instant, this is a local date, this is a time zone, etc. And ask really awkward questions of your product manager saying, well, what happens if it's shipped from the US, goes through Germany, ends up in Australia? What does that do about the warranty period or when they can return things? Be careful anytime it comes to time zones. I've given some of the gotchas. I haven't had time to talk about when time zone rules change. For example, if the European Union says we are going to stop using daylight saving time we'll just be in permanent daylight saving time. We'll stop switching every year, twice a year. That's being discussed, has been discussed for years, might happen. How does your software cope with that? And that comes to a myth of, if you just store UTC, everything will be fine. Well, it's fine if you store the right UTC, but when time zone rules can change, you may be making a prediction that is not backed up by reality. I want to come to one really important tip before we get to questions, which is, this is the most practical slide of the whole talk. It's provided in Noda Time already, but if you want to use it yourself, you can do so dead easily. Just take the code from this, probably rename clock to system clock, to be honest. I didn't have quite enough room on the slide. But this is how you can test stuff. If you use datetime.now or datetime.utc now in your code, it is really hard to test that code. You can say, oh, well, I expect that if I then wait 10 seconds, then something will happen. Well, you don't want tests that have to wait 10 seconds, and you definitely don't want tests that have to wait, several months to wait for a leap year to make sure that your code handles leap years properly. Treat getting the current instant in time as a service that you can inject in the same way that you would inject a database connection or whatever it is. iClock is an interface that you can create yourself with a single method of getting the current instant. It's equivalent to datetime.utc now, but let's make it a method rather than a property, given that it changes over time. And then you can have a system clock, which is a genuine singleton. I'm not a big fan of singletons usually. I've just noticed I've made this class static. It shouldn't be static. It should be sealed though. I'm not a big fan of singletons usually, but the system clock really is a natural singleton. That's what you use for production code, or even test code where you're not going to test anything to do with the clock. If you're testing anything to do with the clock, you build a fake implementation that can return whatever you want it to. And we have those in the Noda Time testing package, which is separate from the main production package. So that's one to really take away. I'm going to skip over this due to time. I've talked about most of this before. Ambiguous times, where date time itself falls down, and if you use really clear variable names, lots of comments, lots of documentation, you can get around some of those limitations. It's just harder to use than a well-designed library. And think about what happens if tomorrow the rules change for, say, Paris to say, well, from 2025, it will be permanently UTC +2 instead of alternating. I'll skip all that because I've spoken about it already. Main thing to take away, put some time in, learn how to do all of this. You can do it. Honestly, it is not beyond the wit of humans to work with date and time information properly. Work out what your requirements are, scope them. Don't support different calendar systems if you don't need to. If you're only storing past values, then maybe you don't need to worry about how you get your date time zone information and how you update it and whether you need to do things with the database, etc. Very, very testable. As soon as you've got a clock, writing time-based tests is really easy and a good idea. And that's it. So any questions, folks?
Well, thanks very much, John, for this wonderful. You've given us a really nice time learning about time. It feels like it's this next level of enlightenment, where you're like, okay, so there's so much more about time. And you said, go investigate.
Yeah.
Yes.
Yeah.
We do have questions, quite a few actually. I'll just run them by you one by one. If someone says, I've been advocating for daytime offset on every project I've been working on. You mentioned that it's not entirely a silver bullet. Can you tell us what are the use cases where the daytime object offset falls short?
Right, so I gave one example in the talk, which is if you don't know the offset, if your user has only told you the date and the time, it's lying if you put, oh, I'll just use a date time offset with an offset of 0. Like that's implying that you have more information than you do. Even using it as an instant, you would usually say, okay, well, I'll represent it. If I don't have a particular UTC offset, but I do know the instant in time, I'll just represent it with an offset of 0. And that's sort of implying some more information than you really have. Obviously, as a biased author of Noda Time, I would say use Noda Time where there are more concepts so you can more accurately say what you mean. But yeah, mostly for date time offset, it's you don't want to give an impression that you have more information than you really do have. In many cases, it is significantly better than date time, though. Don't get me wrong. I'm very glad that it exists. I just wouldn't. If you think about it and think, yes, date time offset is the right match, that's absolutely fine. What I want to avoid people doing is coding without thinking.
Yes. Thinking is not optional, is what a colleague of mine
yes.
usually says. Yes.
Right.
Okay, thanks for this one. What are your thoughts on the design pattern of date only and time only? Specifically, what do you think about the names of the types? Do you find them hacky? Is one of the other questions.
I find them pragmatic. So they had to be added to an existing system which was 20 years old and was trying to also be compatible with VB6 and things. Are they the names that if you were creating a completely new system from scratch with no other context, would you pick date only and time only? No, you probably pick date and time of day. But those have other disadvantages. So I would say they are nicely relatable to each other. So even date and time of day aren't clearly similar, whereas date only and time only is sort of, yes, I'm representing part of a date and time. So I like them on that front. Yeah, I think they were at least close to the best possible option to be chosen, given all the constraints.
Okay.
And I think sometimes we give Microsoft a bit of a hard time for doing things without recognizing all the constraints that they're under. And I'm probably the same when it comes to my criticisms of system.datetime. I'm not entirely sure. I think they could probably have designed it without this horrible kind thing, but I don't know.
All right. So given that, another question is, what is your favorite date or time related bug that you had to fix?
Oh, so I can't remember many that I have actually fixed, but I can remember one. And this is a bit of a gotcha that I didn't mention. I used to work on mobile sync for Google Calendar, Mail, and contacts. And I was focusing on the calendar side, and that's where I became interested in all of this. And converting between the Active Sync, so the Microsoft Active Sync representation and a Google Calendar representation of things, I had to represent all-day events, and I represented them as something that starts at the start of the day and ends at the end of the day. Unfortunately, I thought that meant that starts at midnight and ends at the other midnight. Are those the same thing? Well, not when midnight doesn't exist. So in Brazil, at least it used to be the case that they skip forward from midnight to 1 a.m. when they do a full forward, a spring forward. So I came into work with thousands of exceptions being logged saying, no, you can't do this. And it was people trying to schedule or already had in their Google Calendar trying to synchronize an all-day event starting that took place on a day that was a spring forward in Brazil. And yeah, I learned then about the at start of day rather than at midnight. That's quite a big distinction. I also had a lot of fun with time zone representations in ActiveSync because lots of different mobile phone companies were doing their own ActiveSync client implementations. And the number of ways, I mean, the time zone representation is pretty grim, but the clients were doing the wrong thing in just so many different ways. So having to try to hack around that and say, I will guess that you mean that, even though you've only given half the information that you should have done. Fun days.
Yeah. And final question before we go into the break. Are there any gotchas when writing Noda Time instances to a database? I assume you have to be careful with how you go about converting them.
Yes, so that's a whole other topic, how you represent dates and times in different databases. And my experience is that databases are very imprecise in how they describe their date and time types. In particular, Postgres timestamp with time zone sounds like it's got a time zone. No, it really doesn't. It just converts when you insert it, if I remember rightly. Like, various things are not very well defined. So Noda Time stays out of it entirely. We don't provide you anything, but there are various other projects. So I know that there's npgsql.nodatime or something similar to that that provides Postgres integration for Noda Time, and then there's EF Core support for that as well. So I would encourage you to see whether there's already support. If there isn't, then look at the database you're interested in. What is the closest concept to the concept you're representing in Noda Time? And then write some appropriate converters. But I'm afraid because of the many different ways of talking to databases and the many different databases, it sort of feels like it's outside the scope of Noda Time itself, and also outside of the scope of things I can talk with any degree of accuracy about. I don't actually deal with SQL databases very much. So I'm aware of it as an issue, but don't have very much experience.
Would any of the other libraries with Noda Time for serialization provide any,
so
other solution?
we provide serialization for JSON using both Newtonsoft.json and system.text.json as separate packages, and protobuf conversions, which is handy because I work on protobuf. I don't provide any other kind of serialization. I think there are some others, some of which seem to be using reflection to get at the private fields, which is dodgy because our representation has changed over time and may well change again. Who knows? If it's private for a reason. Don't start depending on it. But there are various. If you look in NuGet for Noda Time, you will find hundreds of packages that integrate, barely any of which I've had any experience with or been consulted about, which is great. I love it that Noda Time is apparently, hopefully, simple enough to use that people can integrate with it without having to ask me for anything. That seems to be a good sign, but it does mean I don't know everything that's available.
Yes. All right, John. It's been wonderful. Thanks again for your session and the answers to all of the questions.
My pleasure. Thank
We're
you.
heading into a break now. From my side, everyone have a wonderful rest of the conference. See you around, and everyone be safe, please. Bye-bye.
Take care.
Thanks, John.
Bye.